good songs.
Yeah, I try to only listen to good stuff.
That happens to me. It's usually a song I
Oh, I understand that. It's like, get out.
Yes.
Okay, all right. If there's no questions, we are just going to get into 4-2. We are all crazy people. So let's do this. I think, yes, we did this in one way. Did we finish this? Let me see. I might have done this on another piece of paper. I think we did finish this. Yes, because I did it 2 ways. Okay, there it is. So let's do this. First thing I want to talk about is, it might be from 4-1, I can't remember, but the idea of parallel versus perpendicular. So what do you think about two lines that are parallel? What must be true about them?
Same slope.
Yeah. Never intersect. Therefore, the slopes must be exactly the same, correct? If they were a little different, that's going to hit that. So that's going to hit there somewhere, right? So they have to be parallel. And we're talking about we're only in a two-dimensional plane. Once you're in 3D, all kinds of weird shit can happen. But 2D slopes have got to be equal, completely equal. Yes? And you're all like, dude, equal is good enough. But here's why I say it that way. What must be, so for parallel lines, are these two lines parallel? What you got, Jeff? I don't know, Jeff. Why can you not tell right now? Just to help you a little bit. What's the slope of the first dude? What's the slope of the first dude? 3, because it's in the right place. What's the slope of the second dude? I have no idea.
It is 3.
So if I add 2, multiply by 3, are these two parallel? And one more thing I want to say. What if this one had a y-intercept of -4 also? Would they be parallel? Yeah. What is the thing about parallel? They should never touch. If I make them have the same intercept and the same slope, aren't they the same line? Do they ever touch? They always touch, right? You guys with me? So if they have the same slope and the same y-intercept, they're the same damn line. Are they parallel then? No. They are so desperately not parallel. Can we stop for a minute? So if they have the same slope, different y-intercepts, they never intersect. They're going at the same rate. So one's never going to catch the other one, or vice versa. So what the hell should happen with perpendicular lines? Yeah. They have to have slopes that are as different as possible. So what is the opposite of 3? There are 2 opposites. What is one way to get the opposite of 3? -3, kick ass. What's the other way to get the opposite of 3? 1/3. So I do both of them. So parallel is exactly the same. Perpendicular is totally opposite. Let me try to see if I can get you guys a little convinced about this. If I graph 3x minus 4 and try to do it with a decent scale for once in your life, Jeff. Oh, shit and a half. That's okay, Jeff, whatever. So -4 and then up 3. 1, 2, 3 over 1. Okay. If I thought that the perpendicular line would be just let's say -3x. So that would be down 3, 1, 2, 3, over 1. Do those look like they're perpendicular? If they're perpendicular, what angle are supposed to create? A right angle. So isn't this too steep, negative? Doesn't that make too big of an angle? So if I made it less steep, it would actually hit at a 90 degrees. So not only do I have to make it negative, the opposite sign, I have to also flip it. So one line that would be perpendicular to this line is negative 1/3 x. And then the y-intercept could be whatever the hell it wants to be. If I make it plus 2, let's see. There's 2, down 1 over 3. With my crappy ass drawing, that still looks like it's a valid what? Right angle. So it's kind of nice. Parallel, completely the same slopes. Perpendicular, totally opposite. Change the sign, flip it. So if one slope is 1/4, here's a symbol for perpendicular, by the way. What's the perpendicular slope? Yeah, what do? You change the sign and you flip it. So you get -4, yeah. You guys gonna with me? So if I ask you, are these two lines parallel or perpendicular? You could do it, Jeff. I don't know, man. I appreciate your faith in me, Jeff. Okay, Jeff. Why can you not currently answer? I don't know what the freaking slopes are. So, of course, what would I do with each one? All right, do it. Oh, wait. Here's line 1. Here's line 2. Solve each one for y. Figure out the slope. See if they're perpendicular or parallel. I'll just stand here. Abdul? Ian? That's right. Current average height. Good. Miriam? You guys like your y-intercept you're getting? Bless you, I think. No. Does everybody pull that? Just subtract the 2x and then do what? Why do I not give a shit that the y-intercept is gross? Because what's the only thing I care about getting? Slope. So who cares what that is? I can make that totally disgusting and we don't care because what's the slope? -2/3. I like it. So if I do the other one, did somebody do that one yet? What'd you guys get? I like it. So this guy's slope is 3/2. Are these parallel? Listen to me, guys. Are those parallel?
No.
Hell no. Are they perpendicular? Yes. Parallel? No. Perpendicular? Yes. Do they have to be one or the other? Did we see earlier one that didn't make a 90 and it also, of course they don't have to be one. They can meet in all kinds of angles. So if they don't meet at all, parallel. They meet 90 degrees, perpendicular. And they can meet at, you have a whole bunch that are neither. Right? Would you learn that? The teacher just did this for a while. So who knows what that was. All right. You guys feeling all right? Does this sound familiar? Not that big of a deal. Give me more of those, Jeff. Okay, I'll give you another one. But let's make this a little more interesting. Find the equation of the line that is perpendicular to 3x minus y equals 5 and goes through 9, -6. Yummy. See how this comes out. I kind of try to think ahead a little bit, but we'll see what I did. Anytime you see me say, find the equation of the line that does shit, what two things do you need to get the equation of the line? Slope and a point. Y-intercept would kick ass, because then I know B, but, if I get any point, I'm good. Do I have a point? Yes. Every now and again, I have a point. I have a point here. Do I know the slope yet?
Yes.
No. Of course not. Not yet. Do you mean you've done something you can figure out what the slope is?
Yeah.
Ah, do we know the slope right now just looking at it? No, hell no, but what piece of information have I given you will only talk about my slope? What piece of this talks about slope? Yeah, perpendicular to this. That tells me what the slope is going to be. If I do what? I know it's perpendicular to that line, so how do I figure out my line slope? What do I have to figure out? I have to first figure out that line's. If I know I'm perpendicular to a line, how do I get my slope? What do I have to know about the other line? If I only knew his slope, I could then figure out my slope, right? All right, so how do I get his slope? Solve for what? Kick ass. So, if I take this, here's a cool thing about algebra. 3x minus 1 is the other one, so 3x minus 1 is the other one. Add y, subtract 5, you get here. So what's the slope of this guy? 3. So what's my slope? Kick ass, kick ass. Hey. Just let me stop for a minute. Do we have the two things we need? Do we have the slope of our line? Yes. Do we have a point that we go through? Yes. You remember how to get the equation of that line now? You got two different ways you could do it. Do we know the y-intercept? Do we? Do we know the y-intercept? Do I have, what would the y-intercept look like? It would be a point where x is 0. So I don't know 0 comma anything. I don't know the y-intercept. So b is not negative 6. Everybody see that? I agree negative 6 is the y value. But why is it not the y-intercept? Because x isn't 0. Just some point off in the distance, yes? So I could use mx plus b, y equals mx plus b, but b is not negative 6. I have to solve for b, yes? We did that kind of example yesterday. Or I could use what else? What's the other one?
Point slope.
Point slope, which almost sounds like a Keanu Reeves movie.
Yeah.
Point slope. Y minus y1 equals m times x minus x1. Okay, let me see. You all know freaking BMX, right? You all know mx plus b, yes? Okay, you obviously have to know this. You also must know this. You must commit this to memory. And if you just remember that m is the difference in the y's divided by the difference in the x's, this is just solving for the difference in the y's. It's just multiplying the x's up. It's one step away from that dumb formula I have to also know. And you all know y2 minus y1 or x2 minus x1, yes? Okay. So I don't care which way you do it. I really don't. I am going to force you to do this way sometimes because, again, this formula is very important every now and again throughout mathematics. So I want you to kind of get a decent foundation in it. So let's do it this way first. Do we know m?
Yes.
Yes. Do I know x1, y1?
Yeah.
Yes. So let's plug and chug. Y minus what? Y minus the y piece equals m times x minus 9, the x piece. So all you got to do, y piece goes here, x piece goes there, slope goes there. And now I can put this in a better form. I can try to solve for y, get stuff together. What can I do on this side? Distribute. So I'll do the first part. Negative 1/3 x. Oh boy. Okay. What's negative 1/3 times negative 9? Yeah, the negatives cancel. 3 goes into 9. 3 times. 1/3 of 9 is 3. What's this? Plus 6. So then one step away. Cha! Okay.
So again, if you ever see me say, find the equation of the line that, it doesn't matter what information I give you, you have to figure out the slope and a point. Once you have those two things, you can do this. Or, you can just plug shit into mx plus b, right? Y equals mx plus b. Y equals m x plus b. Now I can solve for b. See if we get the same thing. Negative 6 equals, what's negative 1/3 times 9? Negative 3. If I add 3, I get b is negative 3. Bam. So that would be the same answer. Okay. Stop for a minute. Is this coming back? Does this sound familiar? Is this? If not, does it make sense? Each of the two equations that describe a line require the slope and a point. If I know the y-intercept, that kicks so much ass, because then I know what b is. I don't have much work to do. If I don't have the y-intercept, shit. Either way I want to do it, I got a little bit of work to do. I got to figure out what b is. Okay. So we got all that. So, here's what we're going to talk about today. Yes, I do have a handout. Oh, that's for later. Okay, I don't have a handout for this because I'm evil. So here's the official fortune. Let's say that there were 2 watermelons in my garden before. Let's say 2 watermelons in my garden at first. 3 weeks later, this is a horrible example, but I'll be okay. There are 4 watermelons. If the trend continues linearly, how many watermelons? Let me do this, sorry. Find the equation relating watermelons and number of weeks. Yeah. Oh my God, Jeff. What are you doing to me? So how much time has gone past when there were 2 watermelons? Isn't that where everything starts? Let me say it the other way. How much time has gone past by the time there's 4 watermelons? 3 weeks. Do you see how that's a point? Time is 3. Number of watermelons is 4. So one point I've got is 3, 4. What's the other point?
2, 0.
Careful, what have I done? What's the first point? What's the first coordinate? Time. 0, 2. So at 3 weeks, there's 4 watermelons. At 0 weeks, there were 2. If I assume that the linear trend continues, so I want you to realize, yes, this is a wordy problem, but it's not that bad because you'll almost always be able to figure out points from what they tell you. If I said our profit in 2000 was $800 and our profit in 2010 was this linear trend, okay, you can figure out the 2 points. What do I always need to figure out the equation of a line? What do I need for the equation of a line? The slope and a point. You with me? Do I have a point? I get 2 freaking points. Right? What's good about one of them? What's really nice about one of those 2 points? It's a freaking y-intercept. So what do I already know? The value of b, kick ass. So what's the only thing I need? Slope, kick ass. So we already know b is 2 because Jeff was feeling really nice for a moment. I gave you the y-intercept. In fact, let's do this. What do you guys think? What letter should I use for this coordinate? Because what's it represent? Yeah, watermelons. And then what should I use for this? Not W for weeks, because I already had W for watermelon. So we'll use T for time. How's that? So let's see if we can do this. What's the slope? How do I figure out the slope? Be careful. I can't quite hear you. Rise over run. So the change in the y's, I could do 2 minus 4 over 0 minus 3. And I get 2/3. The negatives cancel. Is that cool? Get -2 over -3, which is 2/3. Can somebody interpret that for me? What was the top again? Top is the watermelons. So 2 watermelons per 3 weeks. Which makes sense. Every 3 weeks I expect to get 2 more watermelons, correct? So you can always interpret the slope. You just got to know what's the units on the top, what's the units on the bottom. Watermelons divided by weeks. 2 watermelons per 3 weeks. So now my question is still not answered. What is the equation? Do you see how my output is W now? Because X and Y don't mean shit. They're just, variables we thought. Let's just use these. Could have been any variable. Could have been A and B. Could have been whatever. So here I want to use W for freaking watermelons. What's the slope? 2/3. T. Plus 2. There you go. So now if I ask you, how many watermelons, if I expect this trend to continue, should I have in 9 weeks? Can you tell me? How many watermelons should I have in 9 weeks? How do you figure that out? What do you do with 9? Yeah, because 9 is the number of weeks. So again, one level of this problem is remember what your variables represent, which is why I want to use letters that make more sense. 9 weeks. That's not W. Well, that kind of sucks. Sorry. Watermelons, weeks. Sorry. T is time. So that's where I got to put 9. So if I say in 9 weeks, how many watermelons? All you have to do is plug a 9 in. 3 goes into 9. 3 times? 3 times 2? 6 plus 2? 8. So I expect 8 watermelons in a total of 9 weeks. Yes? When should I expect what, Jeff? I don't freaking know. What do you want from me? It almost doesn't matter. When should I have 17 watermelons? Blah, blah, blah. How would I do that? Yeah, 17 is now the number of watermelons. So I'm going to put 17 in for W because that's what represents watermelons. And then what do you have to do? All right, do it. I'll wait. Not the greatest example ever, but it'll work. We don't count it as a watermelon until it grows to some certain size or something. I don't know. If you're freaked out about the fraction, don't be, because what's the first step no matter what? What's the first step to get T by itself? Minus 2. So I get 15 equals this business. Anybody remember how to just kill a fraction directly if it's in an equation? It's just one fraction here, yeah? How do I just kill them? Multiply by reciprocal. 3/2. So I can get my variable by itself. If I multiply by the denominator, I kill the bottom, but I want to kill the whole frickin' for just kill it with fire. So I'm going to multiply by 3/2. 3/2. So I get T equals die. 3 halves times 15. What's half of 15? Or let's do it this way. What's 3 times 15? 45. And what's 45 cut in half? 22 and a half. So I would expect to have 17 watermelons in 22 and a half weeks. I love it. Kick ass. So this is basic. This is a remarkably basic example of observations we make in the real world lead to an equation which leads to me being able to predict stuff. Were there assumptions we made though? Yeah, we assumed the trend would continue. That could become a not valid assumption, but right now we're just going to make some assumptions because we have to. Okay, I like it. So I really want you guys with me. Real world, we make observations. We construct an equation, we can make predictions. Real world, are there other variables that could cause my watermelons to grow at a different rate at any given time? Has it been hot for a while? I don't know if you guys have noticed. Has there not been much rain? Yes. If I have a watermelon farm and I want to grow a lot of watermelons, I need to have money so I can actually irrigate my watermelons. What if I don't have much money? Yeah, so when you get higher up in mathematics, you just start to understand how to incorporate more variables into the mix. That's one thing you kind of talk about. We're going to focus on just making some assumptions and getting some nice equations because we're not ready for all the other variables yet. Okay. All right, let me try to give you guys one to try. In 2004, there were 58 people in Townsville. In 2012, there were, you can do it, Jeff. I don't know, Jeff. Barf. I want to make something that's a little bit decent for you guys. Would you like that? 146 people? Sure. Is everybody with me? If that trend continued, how many should be there now? Now I'm going to make a better point for you, and I'm going to have you do most of the algebra work, but does anyone see 2 points? Yeah. And ask, like, if you're interested about this town, how would you ask a question about the population of the town? What would you kind of ask? If you're interested in this town, give me a question about the population you can ask, like, I don't know. This might be too broad of a thing. You'd say something like, how many people were there in 2007, right? Would that make sense? So our input is time, and our output is people. Does that make sense? Okay. Do you want to use 2004 as an input? If you didn't have to, would you rather not? Okay. You see if you guys are really with me. I really want you with me. What really matters here is how many years have gone by. It doesn't matter what year we started in. So I'm going to call the first year I see, I'm going to call it freaking 0. So I'm going to technically say, let t be the number of years since 2004. Why can we do that? Because we're making the damn equation. We can make all kinds of freaking assumptions. If there were thousands of people, I could let y equal 1,000. So I wouldn't have to write comma 0, 0, 0. I would just know if it said 7, it meant 7,000. We're constructing the equation. We can do that shit. We're technically God with this equation. So what's the first point then? Making that assumption. Assume t equals number of years since 2004. So what's the first point? 0.58. Okay. Now you do the rest of the problem. I want you to get the equation of the line that models the population. So you need one more point. Don't say what it is. Go as far as you can. this one? Give me a second. I always forget this. The glare kind of sucks. Go away. I always pick the wrong one. Is it this one? Nope. This one? Sorry guys, give it a second. No, you're not going to do anything? That's the only one I haven't tried yet. Let's see. I thought one of them worked. Not today. Okay. Alright, we'll just do that. Okay. Just to make sure you're on the right track. What's the other point?
146.
146. I like it. This is where we see if Jeff made a decent slope for everybody. I think so. And this happens often enough that it's okay we're doing a couple examples with this, but remind me, what's really nice about the points I gave you? In fact, we made it happen. What's really nice about one of the points we made happen? It's a y-intercept, so I already know what b is. So all I need is slope. No, slope, yeah. Okay. So we give you guys a few moments. If you didn't realize that, go ahead and figure out what the slope is. If you don't have a clue how to do that, let me know. Right now, if they gave you a problem with 2 points and said find the slope, you should go, oh man, thanks, Jeff. Thank you so much. So just to show you, well, let's see. All right, how did you guys set this slope up? Yeah, so I would call this y2. It does not matter which way you go. But if I go 146 minus 58, I must go 8 minus 0. I've got to go that same way or else I get the wrong slope. In fact, what do you know the slope should be? Should it be positive or negative before we do any calculation?
Positive.
Because this population is going up. So the slope should be positive, yeah. So just make sure your answer is making physical sense. Okay. If you get -3 people in the town, that's probably not good. I don't know what that means. Anti-people. Don't hug them. You will disappear. So 8 minus 0. So I think the top is 88, right? So when this problem hits 88. So M is 11. Now real quick, isn't it 11 over 1 just to be pedantic? You don't have to write 11 over 1, but what are the units on that? People per year. So it seems as if this town is growing by 11 people per year. More than likely it's not perfectly linear, but in some cases it's close enough. I don't know if you guys know, but most population kind of follows an exponential. Because that's the one that talks about if you make more people, then more people are there to make more people, so then the rate of growth is constantly higher, so it's not a straight line, it's a curve. Okay. So what did we say earlier? What do we know B is? No. That's M. 58, because that's the y-intercept. So y equals mx plus b. So then if I ask you, how many people would there be in 2047? What's the first thing you are you going to plug a 2047 in for x? Of course not. So what should I plug in for? Well, it should have been t, Jeff. You're smart, Jeff. You're a smart guy. So if I make this t, what do you think I should make this? P for population or people. So in 2047, what's the first thing I should figure out before I can use this? Yeah, what would t be?
43.
43, kick ass. And then you just plug a 43 in. I don't care what that is. You can just multiply that. What if I said, when will there be 1,287 people? Put that in for P, subtract, divide, blah, 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 blah. Okay, you guys kind of with me? Once you do a couple of these problems, they kind of, and you'll see several problems in the homework for this section that are basically this. They give you information, you make them into points, you make the equation, you throw in whatever they ask. Put it in the right place. Yes. Okay. not too bad, right? You gotta love linear functions. Okay. You don't have to. You could hate them if you want to. Okay, so the main thing I want to focus on for the rest of the class, we're going to get in, that's 4.2. That's all I'm going to say about 4.2 for the moment. You got to get in there and try some of those problems out, see how they go. We're getting into chapter 5. Chapter Jeff. Chapter does not start with an S. Chapter 5. Okay, so I want to say a couple things about chapter 5. Again, I never say this kind of thing to scare you, but chapter 5 is going to be our deep dive into graphing. We're going to learn some general kind of theorem stuff. One of them we already saw when I showed you the video for complex numbers. They said there's something called the fundamental theorem of algebra. And what that says is if I have a polynomial equal to 0 and the polynomial has degree 4, there must be 4 answers. So chapter 5 is going to be, what does a graph look like if some of the answers are complex? What does a graph look like if the degree is 5, 6, 7? Are there differences? Are there general differences? And we already kind of know this. What's the x squared look like? If the highest degree I see in a polynomial is 2, what should it look like? If I have whole number is a polynomial. Parabola. We all know this, right? We all know this. But I understand you guys are always like, he's trying to trick me. I'm never trying to trick you. What about a cube? X cubed. Yeah, it looks like a parabola where half of it fell out, yes? So it goes, my head is the origin. Yes, okay. You guys kind of with me? 4th power, 5th power, 6th power, 7th power, 8th power. Okay, good, gotcha. Even power, odd power. So let me ask you this question right now. This is getting a little ahead of where we want to be. At the ends, if it's an even power, at the ends, what's it doing on both ends? Going to infinity. I love it. If it's an odd power, what's it doing on this end? Going to positive infinity. What's it doing on this end? Negative infinity. We call that end behavior because, again, we're very creative. What's it doing at the ends? We'll call that end behavior. So we're going to see that later in this section. We're going to start with a deep dive into parabolas. Right? Otherwise known as parabolas. Not just one bola, but a parabolas. Can anyone tell me anything about parabolas? Just anything. I'll take anything. They look like you. They look like me. What's the most important point on a parabola? Beautiful, vertex. That is the official name. We also sometimes refer to it as a turning point. Kind of makes sense because this is where it turns. You guys all with me? So if I give you any parabola, one of the most important immediate things to find is the vertex. And so, for example, if I have a profit function and it's parabolic, where do I want to be? Profit function, parabolic, where do I want to be? This represents my profit. Where do I want to be? Right there. So financial analyst's job is basically chasing that. And normally their equations have multiple peaks, but they're always chasing the peak. What do I set the price at so I can get close to that peak? And every second, everything's changing. So that would drive me insane. I'm very happy I don't do that. Can we stop for a minute? Vertex, turning point. Can somebody tell me more about the parabola? Something about the shape of it besides it being a U? Is there a mirror somewhere? So for this parabola, if you just pretend for a moment, it's symmetric around this line. Yeah, this is called the axis of evil. No, symmetry. Which is another fancy name of mirror. That's where the mirror is. So if I shift a parabola around, the mirror goes with the vertex. That's where the mirror would go, yes? Wherever the vertex ends up, the mirror is going to go right through it. That's going to be the axis of symmetry. Can anyone tell me the equation of this axis of symmetry? And that sounds like it's really hard, but what's true about every point on this axis? That's the equation of it. Beautiful. Isn't that silly? That's what equations are. How do you describe every point that this line goes through? X is 0. Okay, done. That's the equation. Okay. So what we've got up here is just x squared, especially if I give it some more. Now, obviously, what I've drawn up here was shit, but now it's a little less shit. Yes? So, dear God, in chapter 5, if you give me an answer that looks like this, that is shit. I need scale. I need work. I need something. Yes? This is nowhere near good enough. Okay. So chapter 5 is going to be very detail-oriented. Oh, shit. Okay. So can somebody tell me, what would this do to what we just had? You guys know this. What would this do? What would these, there's how many transformations?
2.
So it would take the whole picture, and it would move it how? Right 1, up 3. Without actually redrawing this, can anyone tell me where the vertex is going to end up? Where is it currently? 0, 0. So if we move it over 1, up 3, it's going to end up at 1, 3. Okay, I really want you guys with me. Of course, if the vertex starts at 0, 0, and I see some shifts, I can tell where the hell it's going to go. I don't even have to graph it. If the question is just, what's the vertex of this thing? I'm like, 1, 3, that kicks ass. It moves over 1, up 3. You can see that. So let me ask you this. Why is y equal 4x plus 7? Why is that a beautiful way to get the equation of a line? Because what can I tell right away? Y equals 4x plus 7. I can tell what the slope is. It's 4. I can tell what the y-intercept is. 0, 7. Yes? If you give it to me in another form, I've got to do shit. So if I give you a parabola in this form, that kicks just as much ass as mx plus b, because what can I see? I can see the vertex. I can also see one more thing. How do I know this opens up?
Positive in front.
There's a positive coefficient in front of the squared. If you get to calculus, you'll actually see how that relates to the slope. Kind of relates to slope. It should now be going down, not up. This one is up because this is positive 1. Okay, I like it. So if I give you this parabola, tell me anything you know about it. Anything. What you got? Sure, but give it to me more directly. What's the vertex? Negative 11. Negative 49. Kick ass. Opposite of what it looks like. We know that. We've talked about that. Same thing as what it looks like. Goes back 11, down 49. So now it's that. Negative 11, negative 49. Tell me anything else. It's a parabola. Okay, we already said that. What else we got? Tell me something else.
Opening down.
Opens down. How do you know that?
Negative coefficient.
Yes. The first number is negative. Why did that 3 not screw with my vertex? Because it only matters what's in here. It tells me how much the x moves. This is going to tell me, what's that 3 tell me? Before I flip it, here it is normally. What would the 3 do? What do you think? Yeah, every output is now 3 times as big. So you can see that is basically the slope of it in a way, yes? When you get to calculus, you'll actually be able to figure out exactly what the slope is. But normal, 3 times negative 3. So if the number in front is bigger than 1, it makes it skinny. If the number in front is smaller than 1, it makes it open wider. Okay. Opens down, and you can say skinny, narrow, however you want to say that. It's going to be okay. So let's do a problem where, let me give you one that's not quite as insane with the numbers, because I want to graph this. Let's see. What you got, Jeff? I don't know, Jeff. Let's do, sure, negative x plus 2 squared plus 2. I like it. Flippity fruit. So two things you can tell me are, which way does it open?
Opens
Down. And what's the vertex? Okay, I like it. Now there's a third thing I'll ask you right now. And here's you gotta be really careful. What's the y-intercept? It is not 3. Why, when it's y equals mx plus b, why is that last number the intercept? Because when I make x 0, mx goes away. When I make x 0, does that whole first part go away? How do I find the y-intercept? I gave it away just now. Set x equal to 0. And what do you get when you set x equal to 0? You get negative 4 plus 3. Negative 1. So the y-intercept is 0, negative 1. Let me stop for a minute. I do not care what function I give you. How do you find the intercepts? You make the other letter 0. I don't care how many letters I put in there. We're going to get to. But you can have 87 letters in there. I'm borrowing from Russian and Greek or whatever. And it's like, how do you find the omega intercept when you make all the other letters 0? Doesn't matter. So let's see. Let's plot what we know. So we got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So what do we know? We know the vertex is negative 2, 3. We know the y-intercept is 0, negative 1. Let me ask you a fourth thing. What's the axis of symmetry? Heretofore known as the eos.
X equals 2. Negative 2.
Yeah, it moves with the, so it's going to be x equals whatever this is for the vertex, because it moves with the vertex. So there's a mirror right here that you don't have to do, but I'm going to do. I'm going to do it really badly, but that's okay. If that's a mirror, where's there a third point that I don't have to do any work for? That is a mirror. Where's there a third point?
negative 4, negative 1.
So since this is here, there must be 1, 2 this way. It's a mirror. And then I can just connect them and make a parabola. Yeehaw! You guys with me? You can always get a third point by symmetry just using your y-intercept. So if I gave you this problem and it said graph this, I'm going to first ask you to find the vertex. So I don't want to see a table of values. Not only do you not need it, I won't let you use it. Vertex, y-intercept, symmetry point. Let me stop for a minute. Does somebody have a way to check this besides graphing calculator? Because maybe I won't let you use one when I ask you this question. Ha 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 ha. How do you check this? What point is this? You gave it to me earlier, John.
Negative 4, negative 1.
Negative 4, negative 1. So how do I check that this is correct?
Plug it into the
Plug a negative 4 in, and I better get a negative 1 out. So negative 4 plus 2 is negative 2 squared is 4. Negative 4 plus 3 is negative 1. Yay. Whenever you graph anything, whatever point you kind of came up with yourself, just plug it in the function. See if it works. If it works, things look good. If it doesn't work, oh shit. Okay, so let me ask you this. Let me give it to you in a different format. Yeah. Okay. Is that parabolic?
Yeah.
Yes, because if you multiplied it out, what would the highest degree be?
2.
Square. I love it. So I just have it factored, right? Like a silly math boy, I've got it factored. The way it is right now, don't multiply it out. Can anyone tell me anything about this? Can you tell me what the vertex is? In a minute you will, but is it in the right form just to see the vertex? No. But what's in the right form for? Something I haven't asked for yet. X-intercepts. The roots. What are the x-intercepts? 1, 0, 5, 0. And how, you can also answer this question. Which way is it opening? Because it's a positive, yeah? When you multiply it, it'll be positive x squared, so it opens up. So all I know so far is there's an intercept here, there's an intercept here. But that means I know where the frickin' vertex sits on. I know what the x value of the vertex is. Because what's got to be true about a parabola? It must be symmetric. So if I know these 2 points, where's the middle? In the middle, yeah? So what's the x value in the middle of my intercepts?
3.
So doesn't the vertex have to be on x equals 3 somewhere? Isn't that where the axis of symmetry would be, x equals 3? So I know, just by looking at the damn thing, that my vertex must have 3. Must be on this line, because that's where the mirror would be, correct? So how do I figure out what this is? Just plug it in. I know what x is, so can't I just plug it in? What's 3 minus 1? 3 minus 5? 2 times negative 2? Negative 4. So then this will be 1, 2, 3, 4. 1, 2, 3, 4. So what's nice, this parabola is opening up the way it should. Right? So just make sure that it's doing what you... Oh, shit and a half. Make your points really big if you miss them. Okay. Will the x-intercepts always be nice whole numbers? Will we always have real x-intercepts? But no matter what they are, even if they're complex, the vertex will be in the middle of them. Remember that freaky ass video I showed you and the guy put what? So even if the x-intercepts are complex, they're still there. My vertex still has to be in the middle of them. So what the shit do I do if I can't factor it to see what the x-intercepts are and blah, blah, blah? So let me show you. So let's say I have a, here, let me really freak you guys out. Yeah, sure, I'm gonna freak you out. Is that a parabola? As long as A isn't 0, correct? If A were 0, it'd be a line. So we're assuming A is not 0. That's a parabola. Can somebody please tell me how to get the x-intercepts for that parabola? How do we get the x-intercepts? Set y equal to 0. And then how do we get the x-intercepts? And how do I do that? Can you factor this?
You need to move C over.
What multiplies AC and adds to be B? And I'm like, I don't know. Yellow and radish? I don't know what the shit. I don't know. But yeah, how do I solve this? What's built to solve this? There's something built to solve this quadratic formula. I love it. What's a quadratic formula?
B plus or minus.
Negative B plus or minus square root of B squared minus 4AC over 2. I'm going to do this. Is everybody cool with that? Do you guys see what I did? It's all over 2A, so I just put each piece over 2A. I really want you guys with me. Is everybody cool with the fact that whatever the x-intercepts are, my vertex has to be right in the middle of them? Yes? Must be right in the middle of them because that's where the mirror would be. Even if they're complex, I still have to be right in the middle of them. Does everybody see how the x-intercepts for any damn quadratic in the universe is given by this thing? Yes? I don't normally write it like this, but I can. Does everybody see how it is this plus and minus the same stupid thing, yes? I need you to see. So if I do negative b over 2a plus this, I get one x-intercept. If I do negative b over 2a minus this, I get the other x-intercept, yes? So where's the vertex? What's the x piece of the vertex? What's in between my two x-intercepts? Freaking negative b over 2a. That's a shortcut. How do I find the x piece of a vertex? I just have to do negative b over 2a. Why? Because that's always in the middle of my x-intercepts. So let's do this one again. Let me not go too fast. Sorry. You're like, that's all you ever do, Jeff. I'm sorry. Write this a little better. That piece didn't matter. Has anybody ever seen this before? This is a shortcut to find the vertex. I don't know how it was explained to you, but oh well. In calculus, you'll show that a different way. But for right now, we got this. So I'm gonna destroy that piece of paper. I'm gonna do this problem, this problem again, but I'm gonna multiply it out. So this is the same parabola. Yes, if I multiply this out, I get this. And I claimed that this is a shortcut to get the vertex. And the vertex we got was 3, -4, right? We got this vertex already. So let's see if I get the same vertex this newfangled way. What's B? Notice how there's a negative in the equation, and then B is a negative. And what's A? 1. -6 is 6, divided by 2 is 3. And then if I plug that in, I get the y piece. So I got 3, -4, which is the same damn thing we got before, yes? You guys kind of with me? You guys all right? Some of you guys look like you're in pain. I'm sorry. Okay, so here's the ultimate. Well, let me see. Do I have more weird shit here? No. Oh, beautiful. So let me ask you this question. Does this function, does this parabola have a maximum or a minimum? Yeah, how do these people, listen to these people, how do they know that shit? Why does this have a maximum? Because it opens down, so the maximum would be in my head, right? Okay. If it opens up, minimum. Opens down, maximum. Can somebody find the maximum value of this function? Where does it occur? At the vertex. So when I say find the maximum value of this parabola, you can translate to say find the output for the vertex, find the y piece of the vertex, or find the vertex, right? How do we find the vertex? What's the shortcut? -b over 2a. What's b? 12. And what's a? So I get -12 divided by -6? 2. So how do I get the actual maximum value? Plug 2 in. So I get -12 plus 24 minus 4 is 8? Yes. So that would be my maximum. If this is my profit function, this is thousands of dollars, the maximum profit would be $8,000. So you will see problems that say find the minimum cost. So then that just means to take the cost function they gave you, do -b over 2a, and then plug it in. Figure out what the output is at the vertex, because that would have a minimum. Okay. So now we should know enough with very little time, Jeff. It's just the way it goes. So here's this worksheet. Should be an extra one, right? Is it right here? Yeah, thank you. So try to do the first two. These first two, either you understand them and you're done, don't understand and you haven't got it. So the first one here, what's the vertex? You can just see it, right?
-1.
2, -1. Does it open up or down? Because the first number is positive. People freeze up when they see this problem, but we don't care. I don't care that it's got a decimal. Who cares? What's the vertex?
Negative
-5.1
to 13.
Good, because it goes back 5.1, it goes up 13. Does it open up or down?
Down.
Because it's negative. Yeah, okay, cool. So let that be nice. So let me do one problem here on the side. You might want to, let's do it on the back of this guy. What if I have, so I'm pretty sure this is in the homework. Let's do a simple one first and then a more freaky one. Is that in the right form to see the vertex? Can I just see it? I'd have to do work. I have to either do the shortcut, but what if Jeff, the asshole Jeff says, don't use the shortcut. Put it into the right form. So what is the correct form to see the vertex? Isn't it something like a number times x minus h squared plus k? I'm just going to use the standard letters. Turn this, Jeff. There you go, buddy. Because if you saw this, what would the vertex be? My God, Jeff.
H.
There we go. It would be HK, yeah? That's not in this form. It's sort of like putting something in the form y equals ms plus b and then everything falls into place. So here we go. Let's see who gets this. Do you guys see what I need to do to put it into that form? This was what we did before we officially knew quadratic formula. We had to complete the square. Oh, shit. So I'm going to make some room. I'm going to move the 2 over. And what are my 2 steps? How do I figure out what number goes here? Take the -4 and cut it in half. And then take that number and square it. This is what I put. Now watch this. You guys ready? If I add 4, I better at the same time on the same side do what? So that overall I did nothing. If I add 4, at the same time I better subtract 4. Did I change the problem? No. Somebody's like, I got 7. All right, I'm going to take 3 away and then give 3 to you. Did I change it from 7? No, it's still freaking 7. If I add 4 and subtract 4. And I always like to say this, but so few people, this makes me so sad. So back in the 80s, people know how to make movies. Yeah, anybody ever seen Indiana Jones? Very first one, Raiders of the Lost Ark. And of course, you know what scene I'm talking about, maybe. He took the gold idol and then he put the bag of sand in the boulder, right? So if I subtract 4, I better at the same time add 4 so the boulder don't come and kill me. Yes? And all this shit happen. You guys kind of with me? So if I take 4 away, I better add 4. If I add 4, I better take 4 away. So that it balances. So Indiana Jones didn't really count as sand. He didn't really feel the sand correctly, poor little dude, so it didn't balance. And the boulder came down. Boulder's a big math guy. So careful, kids. All right, so if I add 4, I have to add 4. I better subtract 4. So how can I factor this piece now? Remember that first step tells you how to do it. And what do I get out here? It's 2 minus 4. Yeah. So watch this. If I did the vertex shortcut, what would I get? If I do the vertex shortcut, what would I get? What's B?
4.
Yeah, -4 is 4, divided by twice 1. I get 2, and if I plug 2 in, I get 4 minus 8 is -4 plus 2 is -2. Isn't that what I get here? What's the vertex?
2, -2.
Same thing. Beautiful. Kick ass. So here's where everybody really, really enjoys this. You ready? So that was an easy one. I'm sorry, close your eyes. So over here it would still be 2, -2. So I get the same answer both ways. So here's where things get weird. What if I have this? What do you have, Jeff? I don't know. Sure. Sure. There we go. Why not? Look at that. That's yummy. Does anyone remember what completing the square requires the first coefficient to be? That's why this was nice. So I'm going to take a 3 out and push the 7 over. Let me see if you guys are cool with that. I took a 3 out of these, and the 7 I just put out here. Now let me ask you guys. Does everybody see a -8 in this? You guys see it? -8x? There it is. Is there a -8x in the original function? No, it's a -24x, correct? Because it's 3 times this. Okay, so keep that in mind. How do I figure out what number goes here? Half the 8, and then take that and square it. So now watch this, you ready? Okay. It's going to be weird. So when I write this, I did not just add 16. That's not what I just did. I did not just add 16. Does anyone see what I added?
48.
I added 48. Same way if I ask you, is there a -8x? No, it's -24 because it's 3 times this. So when I put a plus 16 there, I actually just added 48. So at the same time, I better subtract freaking 48. The first one is easy because there's just a 1 out front. Didn't do weird stuff to me. Now a stupid 3. Damn you 3. So what do I get? How do I factor this? I always factor it according to the first step. And over here I get so what's my vertex?
4, -41.
Sweet. Does it open up or down?
Up.
Up. So this would be the location of a. This is max or min? Min, because it opens up. Kick ass. It's got a valley. It's got a minimum. Okay. Yes. Such a wide variety of reactions. Everybody got that? I'm sorry. You got that? So the negative b over 2a is a shortcut. We still have to understand how to do this. Yeah, let's call it a day. We'll finish this up tomorrow. That's the plan. What do you guys think? Anybody upset if I call it a day? If so, take it up with the chair. Is Miriam out there?